Over the past 200 years, the ocean's carbon dioxide absorption rate has hovered between a quarter to a third of all anthropogenic CO2 in the atmosphere. Ocean acidification is often referred to as the other CO2 problem because both it and climate change are directly affected by the increased levels of CO2. Since the pre-industrial era, these CO2 levels have increased approximately 40%. The current 392 parts per million is drastically higher than the pre-industrial levels of 280 parts per million. This increase is mainly due to human activities of burning fossil fuels and deforestation. The recent rate of CO2 increase is unlike anything the Earth has ever seen. Ocean acidification, the process in which CO2 is dissolved in the ocean and other water basins. As the gas dissolves, the CO2 reacts with the water to create carbonic acid, H2CO3. Carbonic acid then dissociates through the loss of hydrogen ions and becomes bicarbonate, HCO3, and carbonate, CO3. The increase of hydrogen ions in the water results in the lowering of the pH, and it also leads to the decrease of carbonate ion concentrations. The pH of the pre-industrial ocean, which was approximately 8.21, has since fallen to about 8.1. This decline may appear to be negligible, but when fully understood, using a logarithmic scale, it indicates a 30% increase in the ocean's acidity. If the CO2 trends continue at the current rate, it's expected that the pH will decrease further by nearly 0.3 to 0.4. This indicates a monumental change within the ocean that will deeply impact its species. The oceanic food chain is highly important when analyzing global change. This can be seen in calcifying organisms. Ocean acidification is well known to lower the saturation levels of calcium carbonate. The decrease in carbonate ions directly affects calcifying organisms, as they rely on these minerals to form and maintain their shells. These species, which include plankton, echinoderms, and corals, rely on aragonite and other carbonate minerals. As the pH continues to drop and the amount of these carbonate minerals decrease, these species will experience a harsher and less hospitable environment due to the dissolution of their shells. There are some serious implications for specific species of fish if CO2 levels continue on the same track or are not reduced enough in a timely manner. One observed effect resulting from the increased absorption relates to olfactory senses in some species of fish. The larval development stage is a delicate and vulnerable step in the life cycle of fish. Larvae typically rely on olfactory cues to distinguish what should be familiar territory from unknown and possibly dangerous habitats. Studies with clownfish larvae and pH conditions expected to occur within the next century show a massive disturbance in this sense. Many cases under study do indicate that the larvae lose all olfactory and homing sense, and as a result are unable to distinguish safe oceanic zones from dangerous predatory zones. This loss of sense poses a serious threat to the preservation of their species, and if similar species exhibit like patterns, then the ocean and its natural balances may be gearing up for some catastrophic alterations. In reality, we live on planet Ocean, not planet Earth. For a body that covers 71% of the planet's surface, we should take greater care to prevent the human-influenced destructive forces like ocean acidification. It's now up to us to try and right tomorrow's wrong. So today, we sing tomorrow's song.